Geometry Common Core, the June 2016 Regents exam, starting on number 31. So in the diagram below, radius OA is drawn in circle O. Using a compass and a straight edge, construct a line tangent to circle O at point A. And of course, leave all your construction marks. All right, so here's circle O, and we want to create a tangent at point A. And just to draw, don't write this for a second, but the difference between a line going like this and a line going like, this, although I didn't hit the circle, this would be a tangent line, and this would be a secant line. A secant goes through the circle, hits the arc in two separate spots. A tangent line hits the circle only in one spot. And so we're talking about drawing a line that only hits the circle in one spot. It doesn't ever go through. It kind of brushes the edge. And so that's a tangent line. Now, the important thing here is a major property of tangents is that wherever a tangent hits the circle, if a radius is drawn to that point, they are perpendicular. So what this construction is really asking you to do is perpendicular through a point. We want to draw a line through point A that's perpendicular to OA. So that's really the task here. Now, I think on the Regents exam, the circle is not quite so close to the question, so you're not like drawing on top of the words. But, one of the things the students forget they can do in constructions, which is very helpful, is extensions. I can extend this line, and that's going to be necessary for me to do this construction. But I could extend that line, and then I could use my compass and do a perpendicular construction. The way perpendicular works is you pivot the point you want to be perpendicular around. And you just draw your arcs so that it hits your line in two spots. The two spots that your arc hits your line are going to become pivot points. Oops, don't want to move that. So 1 and 2. And this is why it was necessary for me to extend that line, because it's hitting out here. From those two locations, I need to draw arcs. Now, I can't draw at the same setting because then those arcs won't cross at all. So I actually could extend my compass really to any length, as long as it's bigger, draw an arc from one of those points, and then draw an arc from the other one. Where they cross is the point that I connect to my original pivot point. And that is how we get perpendicular through a point, and that is what a tangent is going to be. So there's usually only one construction per Regents exam, sometimes two, but usually only one. But they like questions like this where it's not just as simple as telling you what to do. Like you had to know that a tangent and a radius are perpendicular. And so, they didn't just come out and say, draw a line perpendicular to point A. It was draw a tangent, which you needed to know was perpendicular. And, I think that's what a lot of the construct. Some of them are straightforward, like, construct a square inscribed in a circle. And make sure you know how to do the hexagon, the square, and the equilateral triangle inscribed in a circle. They've come up several times. But other than that, sometimes it's kind of reading in between to find out what you actually have to do. Number 32, so this is where the part 3s begin. So these are 4-point questions. Like with the last couple of groups were part 2s, they were only 2-point questions. But now we're in the part 3s. And I believe there's 3 part 3s, 32, 33, 34, and then you get to the part 4. And so 3 part 3s, these are important questions, 4 points each. A barrel of fuel oil is a right circular cylinder. So right away I'm thinking volume equals pi r squared height, where the inside measurements of the barrel are a diameter of 22.5. So if diameter is 22.5, right away I'm thinking, all right, what's my radius? Cut 22.5 in half. So turn on my calculator. I'm definitely going to need it for these volume questions. 22.5 divided by 2 gives me a radius of 11.25. And the height is 33.5. There are 231 cubic inches in a liquid gallon. Determine and state the nearest tenth the gallons of fuel that are in the barrel. So there's 230 cubic inches in a liquid gallon. So we need to know how many gallons we have. We need to know the volume. So we are doing the volume formula of our cylinder to start. So pi times our radius of 11.25 squared times our height, 33.5. This is approximately what? So let me type this whole thing in. So let's see. We have pi times 11.25 squared times 33.5. Oh, missed a 3. And that comes out to be 164.4427. Now, I'm not going to round anything, but I'm going to write it out a couple of decimals so I can work with the number 164.4427. So 164.4427 and some other numbers after that. And I'm going to use the whole number in my calculator when the time comes. So this is how many cubic inches we have. And there are 231 cubic inches in a liquid gallon. So I'll set up a proportion here. 231 cubic inches is 1 liquid gallon. Well, our answer of 164.4427, so on, is how many liquid gallons? So determine and state to the nearest tenth the gallons of fuel that are in a barrel. Cubic inches in a liquid gallon. Well, it seems like the answer is going to be less. So let's cross multiply here. This ends up being times 1. So we end up with 231x equals 164.4427. And so I'm going to have to divide by 231, and I'm definitely going to get less than 1. So what I can do is take that entire number in my calculator, because it's already there, and divide by, what was it, 264? 231. 231 comes out to be 0.7118, and we want this to the nearest 0.7118, so to the nearest tenth is 0.7. Okay, just reread the question. The inside has a diameter of that, a height of that. Sorry, we accounted for the diameter. There's 231 cubic inches in a liquid gallon. We have less than that. Determine and state the nearest tenth the gallons of fuel that are in the barrel of fuel oil. Yep, okay. Number 33. Given parallelogram ABCD, EFG, and diagonal DFB are drawn here. Prove they are similar. For similarity, proving similarity, we could do angle, side, or side, side. But when it comes to proofs, we typically only are going to work with angle. Not every time, but there's no mention of side proportions or anything like this. They're not giving me any numbers. So I'm looking for angle. Now, it's always helpful to highlight the triangles you're working with. D, E, F. So here's D, E, F. I want that triangle similar to B, G, F, this triangle here. And so I'm looking for angle congruencies when I'm doing similarity. The first thing that jumps off the page to me is I have vertical angles. So that's 1. The second thing is that you're given a parallelogram. And when you're given parallelogram, you have parallelogram properties. And one of those properties is that opposite sides are parallel. And with these parallel lines, we're going to have that Z pattern and alternate interior angles. So these angles here and here are alternate interior. So I'm going to call these 1 and 2 because I saw those first, and I'll call these 3 and 4. Now for the statement and reason proof, let me do this down here and extend the page. So statement and reason. So the first thing I'm going to say is A, B, C, D, or let me actually, is a parallelogram. We'll just say that. Is a parallelogram. and that's given information. And I suppose because we're stating that, maybe I'll use that, and so I'll kind of reverse the order of these. That's okay. And so because of that, I can say AD is parallel to BC because the opposite sides of a parallelogram are parallel. And because of that, angle 3 is congruent to angle 4 because alternate interior angles of parallel lines are congruent. You really need to make sure that when you're doing alternate interior, you have of parallel lines in your reason. You can't just say alternate interior angles are congruent. You have to explain it's coming from the parallel lines. And before you can do that, you have to state you have parallel lines. So that is that. And then the last piece here was that angle 1 was congruent or is congruent to angle 2 because vertical angles are congruent. And then lastly, that means triangle DEF is similar to triangle BGF by the angle, angle theorem. That's it. The other option for this question, because of the parallels, we could have also said these angles were alternate interior and just do 2 pairs of alternate interior. But we covered both the alternate interior and the vertical here, so we're fine. So that's it. That's a really nice, short, simple proof. The part 3 proofs aren't too bad. The part 4 ones are typically way more involved. Okay, so we're reaching, so here's 34. This is the last part 3, but we are reaching the over 12-minute mark. Let's see, it's dilation. Yeah, maybe I'll save this for the next video because I don't want to rush through anything, especially at part 3. So the next video, maybe I'll do 34 and 35 together, and that'll be it. Now, there is a 36 in this because there was, at this time, in the first couple of exams, there were 2 part 4s. The state has since changed that. So I will do this question probably in a separate video, but you no longer have a second part 4, and what they specifically took out was the volume part 4. So there's no longer a volume part 4 question. But I will make a video for it, but you won't have a volume question quite this complex on your Geometry Regents exam. And looks like this first part 4 is another proof, which is going to be way more involved than the proof we just did for number 33. All right, but we'll tackle those in the next video. See ya.